Welcome all. Let's discuss on endodontic instruments. Although a variety of instruments used in general dentistry are applicable in endodontics, some special instruments are unique to endodontic purpose. The first endodontic file was made in mid-1800s by Edward Maynard by notching round wires. 1958 is considered as a hallmark year in the history of endodontic instruments when England Levin proposed the standardization of endodontic instruments. Now let's discuss on standardization of endodontic instruments put forward by England Levin in 1958. Earlier, root canal instruments were made according to the whim of manufacturers with no definite specifications. England Levin did a research study using an electronic microcomparator and found variation in the diameter and taper for same size of instrument from different manufacturers. The manufacturers came together and a consensus was made for standardization. They suggested some guidelines for instruments for having uniformity in instrument diameter and taper. So they proposed that instruments shall be numbered from 10 to 100. The numbers to advance by 5 units from size 10 to size 60, and then by 10 units from size 60 to size 100. This has been revised to include numbers from 6 to 140. Each number shall be representative of the diameter of the instrument in hundredths of a millimeter at the tip. So number 10 is 10 divided by 100 or 0.1 mm at the tip. Similarly, size number 25 represents 0.25 mm at the tip, and size number 90 represents 0.9 mm at the tip. The working blade for flutes shall begin at the tip, designated site as D0, and shall extend exactly 16 mm up the shaft, terminating as designated site D60. The diameter of D16 shall be 32 by 100 or 0.32 mm greater than that of D0. This sizing ensures a constant increase in taper of 0.02 mm per mm for every instrument regardless of size. So a number 20 reamer shall have a diameter of 0.20 mm at D0 and a diameter of 0.20 plus 0.32 mm, that is 0.52 mm at D60. The following specifications were added later. The tip angle of an instrument should be 75 plus or minus 15 degree. Instrument sizes should increase by 0.05 mm at D0 between numbers 10 and 60. Example number 10, 15, 20, and they should increase by 0.1 mm from numbers 60 to 140. Example numbers 60, 70, and 80. Size numbers 6 and 8 have been added for increased instrument selection, especially for fine narrow canals. Instrument handles have been color coded for easier recognition. Now let's look into the different components of an endodontic file. One should have a knowledge of what is the taper of an instrument. So taper denotes the per millimeter increase in the file diameter from the tip towards the file handle. The taper is denoted either in numericals or in percent. The traditional ISO instruments were standardized to have 0.02 or 2% taper. Next is flute. Flute is the groove or relief on the working surface of the file which collects the debris as the file cuts through the substrate. Next one is blade or cutting edge. It is the working area of the file and is the surface with the greatest diameter that follows the flute as it rotates. Land is the surface projections axially from the central core to the cutting edge between the flutes. This feature is incorporated to reduce canal transportation and supports the cutting edge. Next feature is pitch. Pitch, it is the distance from one cutting edge to the next. So a file with short pitch will have more spirals than a file with a longer pitch. Now let's see what is a rake angle. This is one of the most important features of a file. So on perpendicular sectioning of a file, the angle formed by the leading edge and the radius of the file through the point of contact with this radicular wall is known as the rake angle, as you can see in the picture shown. If it forms an obtuse angle, then the rake angle is considered to be positive. An acute angle is termed as a negative rake angle. Another important aspect of a file is the helix angle. So helix angle is the angle the cutting edge forms with the long axis of the file. Now let's discuss on the classification of endodontic instruments. According to the function of the instrument, Grossman has classified endodontic instruments into four categories. The first one is the exploring instruments, that is to locate canal orifices and determine the patency of root canal. Examples include smooth broaches and endodontic explorers. Second is debriding or extirpating instruments, that is used to extirpate the pulp and other foreign materials from the root canal. Example is a barb broach. Next is cleaning and shaping instruments, that is used frequently for shaping and the canal space. Examples include reamers and files. The last is the obturating instruments, that is to pack gutta percha points into the root canal space. Examples are pluggers, spreaders, and lendilospirals. Next, based on the method of use, endodontic instruments are classified into four groups. Group 1 includes hand-operated endodontic instruments. Examples are barb broaches and rasps, K-tape reamers and files, and headstone files. Group 2 includes low-speed instruments with latch tape attachments, which includes gauge clearance drills and piezo reamers. Group 3 is engine-driven instruments, which includes rotary nickel titanium endodontic instruments, reciprocating instruments, and self-adjusting file. Group 4 includes ultrasonic and sonic instruments. Now let's discuss in detail about group 1, that is the hand operated endodontic instruments. First instrument in the series is broaches and rasps. So let's first discuss on broach. There are actually two types of broaches. First is barb broach, second one is smooth broach. Barb broach is one of the oldest intracanal instruments used in endodontic purpose. It is a short-handled instrument meant for single use. You can see surface spikes known as barbs on the surface of the barb broach. They are available in a variety of sizes, from triple extra fine to extra coarse. Coming to the uses of barb broach, the most important function is to extirpation of entire pulp tissue, then removal of cotton or pepper points lodged in the canal, removal of necrotic debris and foreign materials from inside the root canal. Next is smooth broach. Smooth broach differs from barb broach because of the absence of barbs, that is, it is free of barbs on the surface. That's why the term smooth. Previously it was used as pathfinder, but at present flexible files are used for this purpose. Next instrument is rasp or rat tail files. Rasp has similar design to barb broach, except in the taper and barb size. Barb size is smaller in rasp than in a broach and have more taper. It is also used for extirpation of pulp tissue from the intracanal space. Now let's discuss on K-type reamers and files. In the early 1900s, Kerr Manufacturing Company designed and manufactured new K-type endodontic instruments to improve the efficiency of root canal preparation. Till now, it is one of the most important instruments for canal cleaning and shaping. The name K stands for the manufacturing company, that is known as Kerr. Reamers and files are canal enlarging instruments, traditionally made from stainless steel and have different types of spirals and cutting flutes. Reamer, as the name suggests, it is used to ream the canals, that is, it is used in a rotary motion. It cuts by inserting into the canal, twisting clockwise 1/4 to half turn, and then withdrawing, that is, penetration, rotation, and retraction. Reamer has a triangular blank and lesser number of flutes compared to the files. Number of flutes in reamer ranges from 0.5 to 1 per mm. Next instrument is K-file. Traditionally, it has a square cross section and manufactured from stainless steel wire. K-file has 1.5 to 2.5 flutes per mm of their working end. So, as we discussed, it has more number of flutes compared to reamers. File is predominantly used with filing or rasping action, with little or no rotation in the root canal. That is, it is moved only up and down motion. It is placed in the root canal and pressure is exerted against the wall. An instrument is withdrawn while maintaining the pressure. Now let's have a brief look into the difference between files and reamers. So coming to the cross section, files have a square cross section while reamers it is triangular. Area of cross section is more for files and less for reamers. Number of flutes, as we discussed, it is more in files, it is almost 1.5 to 2 per mm, and is less in reamers, that is 0.5 to 1 per mm. Flexibility is less for files and more for reamer. Cutting motion, mostly it is rasping and penetration, that is push and pull motion with files, and it is rotation and retraction with reamers. Preparation shape is usually ovoid for files and round for reamers. Transport of debris is poor because of tighter flutes in files, whereas in reamers there is better transportation of debris because of the space present in the flutes. There are a few modifications for the K file. The first one is K flex file. As the square blank of K file results in total decrease in the instrument flexibility. To maintain the shape and flexibility, K flex file was reduced. The K-flex file is rhombus in cross-section having two acute angle and two obtuse angle. The two acute angle increase the sharpness and cutting efficiency of the instrument, whereas the two obtuse angles provide more space for debris removal. Next modification is flexo file. It is similar to K-flex file except that it has triangular cross-section. This feature provides more flexibility and an ability to resist fracture. Tip of file is modified to a non-cutting type. The next modification is triple flex file. It is made up of stainless steel and has triangular cross section. It has more flutes than reamer but lesser than a K file. The triangular cross section provides better flexibility. Flexar file or Ron file. It is a modified K file that was introduced by Ron. Flexar file is made by removing the sharp cutting edges from the tip of the instrument. Non-cutting tip enables the instrument to traverse along the canal rather than gouging into it, so that it maintains the canal centering ability. This design of Flex R file reduces the ledge formation, canal transportation, and other procedure accidents when used with balance force technique. So this is the instrument that is used in the balance force technique. Another feature of Flex R file is presence of triangular cross section, which provides its flexibility to be used in curved canals. It is made up of nickel titanium and cuts during anti-clockwise rotary motion. Next instrument is headstone file, or commonly called as H file. H file has flutes that resemble successive triangles set one on another, giving a Christmas tree appearance. It is made by cutting spiral grooves into the round tapered steel wire. H file has positive rack angle and is thus more aggressive in cutting, that is, the cutting efficiency is maximum with H file. It has a single helix teardrop shape in cross section. H file should be used in straight canals only because it is strong and aggressive cutter. Since it lacks the flexibility and is fragile in nature, the H file tends to fracture when used in torquing action. So H file should never be used in a rotary or reaming action. So the advantage of H file is that it has better cutting efficiency and push debris coronally. However, the disadvantages are it lacks flexibility, tends to fracture easily, and it is an aggressive cutter. So you should be very careful when you use H file for root canal instrumentation. And H file should be used in only one direction, that is retraction. It should not be used in torquing motion as it tends to fracture. Now the modifications for the H file also. So it's the safety headstone file, high flex file, uni files, S file, and A file. We can discuss one by one in detail. The safety headstone file is a modification of headstone file with a non-cutting side in order to prevent ledging in curved canals. So you can see the difference in the picture. Hyflex file is a modification of H file which has a cross section that represents an H shape instead of the traditional single helix teardrop cross section of the H file. This makes Hyflex file more flexible compared to headstone file. Unifiles are modified edge files that are machined from round stainless steel wire by cutting two superficial grooves to produce flutes in a double helix design. So they are less subject to fracture, less efficient, and they are no longer marketed nowadays. Next is S file. It has a double helix cross section and is a variation of the unifile. It is different than H file. S file has good cutting efficiency in either filing or reaming action. Thus, this file can be also considered as a hybrid design. Next modification is A file. Its cutting edges are at an acute angle to long axis of the file. So when used in curved canals, flutes on the inner edge collapse, so no dentin is removed. Whereas on the outer edge, flutes open, firing the dentin on the outer curvature. This helps in the prevention of ledge formation in curved canals. Next instrument is C++. It is made from specially treated stainless steel. They have amazing stiffness and strength to be used for difficult and calcified canals. They have better buckling resistance compared to K5. Next is golden medium file. It comes under intermediate files provided with half sizes between conventional instruments. So they are available in sizes from 12 to 37 like 12, 17, 22, 27, 32 and 37. They are used for narrow canals since it provides more gradual increase in the size than conventional files. Now let's look upon the group 2 instruments, that is low speed instruments with latch type attachment. The first instrument in this series is gauge splitting drills. As you can see in the picture, they have flame shaped cutting point mounted on long and thin shaft. They are side cutting instruments with safety tips. They are available as a set of 6 instruments with sizes from 1 to 6 and the corresponding diameters from 0.5 to 1.5 mm. They should be used in brushing motion at speeds of 750 to 1500 rpm. The safety design of GG drill is that its weakest part lies at the junction of shank and shaft of the instrument. So if its cutting tip jams against the canal wall, fracture occurs at the junction of shank and shaft but not at the tip. This makes removal of fracture drill from the canal easy by grasping the with pliers. The GG drills or plate drills are used for the enlargement of the root canal orifices, for coronal flaring during root canal preparation, for removal of lingual shoulder during the access preparation of anterior teeth, during retreatment cases for removal of the gut aperture. There is a modification of a GG drill, that is the flexo gates. So the difference is that they are made up of nickel titanium and have non-cutting tip. They are more flexible compared to the GG drill and used for apical preparation also. So the advantages of flexo gates include it allows better debris removal, smoother and faster canal preparation, safe non-cutting guiding tip, so it maintains the canal centering ability. It has a safety design, that is its breakage point is 16 mm from the tip, so once fractured it can be easily retrieved. It's flexible, so it can be used in curved canals also. Next instrument in the group is piezo reamers. Piezo reamers are also stainless steel instruments like gauge splitting drills, but they differ in that blades spread over a wide surface and their shape is roughly cylindrical or double flame shaped. They are rotary instruments mainly used for post-paste preparation. They also have a safe-ended cutting tip. Tip diameter varies from 0.7 to 1.5 mm. They should be used in brushing motion only. So the main use of piezo reamer is for post-paste preparation when gut aperture has to be removed from the obturated root canal space. Now let's discuss on group 3 or the engine-driven instruments. First in the group is nickel titanium rotary endodontic instruments. These are most commonly used in the modern endodontic practice. These instruments are made of nitinol, that is nickel titanium. It is an equiatomic alloy composed of nickel and titanium. They exhibit shape memory, that is ability to return to its original shape once the stress is removed. They can be employed in a truly rotary or 360-degree revolution within a curved root canal because they have high flexibility compared to the stainless steel instruments. There are a wide range of instruments in this series with different generations, different heat treatment procedures, and different manufacturing techniques. Few of the examples are Profile, Protaper Gold, Lightspeed System, K3, Hero 642, FKG Race System. So when you use these rotary instruments, you need special motors for that. That is known as the endo motors for the nickel titanium rotary instrumentation. So there are various groups of that. The first one is gear reduction handpiece, that it reduces the gear. The most commonly used is the electric or battery powered slow speed endodontic motors with torque control, so that here both speed, gear as well as the torque can be controlled. Example is X-Smart. X-Smart EC cordless endodontic motors. They are a group of instruments that is most recently or most commonly used nowadays, that is the cordless endo motors. So they are more ergonomic and they are lightweight also. Next group of instrument is the reciprocating instruments. They function at unequal bidirectional angles. So as you can see in the picture, they have 30-degree clockwise and 150-degree counterclockwise movement. This reciprocating movement allows a file to progress more readily, cut efficiently, and effectively expel debris out of the canal. So they are more advantageous when you compare it to the full rotary movement. Examples include wave one system and reciproc system. Next is self-adjusting file. It was introduced by Zvi Metzger. The file three-dimensionally adapts both longitudinally and along the cross-section of the root canal system. So it can be considered as a canal adaptive endodontic instrument that adapts themselves to the root canal anatomy. So the advantage is that it will not change the root canal anatomy or the root canal shape. So this results in uniform cutting action of the dentine and preserves the basic shape of the root canal. Now let's discuss the group 4 instrument, that is ultrasonic and sonic instruments. Ultrasonic instruments were developed mainly for cleaning the root canals and have a limited role in shaping. The ultrasonic instruments consist of a piezoelectric or magnetic unit that generates ultrasonic waves. Piezoelectric units are better because they are more powerful and generate lesser heat than compared to the magnetostrictive system. The handpiece holds a K file or a specially designed diamond file. When activated, produces movements of the shaft of the file between 0.001 and 0.004 inch at a frequency of 25 to 30 kHz. The oscillating file movement produces the cutting action of the file and creates an ultrasonic wave of irrigant solution. The ultrasonic vibration produces heat that increases the chemical effectiveness and bactericidal action of the irrigating solutions. Coming to the mechanism of action of the ultrasonics or the biophysics of ultrasonics. There are two mechanisms by which ultrasonic acts. First one is called as cavitation, the second is called as acoustic streaming. So what do you mean by cavitation? Cavitation is the growth and collapse of bubbles with a resulting increase in the mechanical cleansing activity of the irrigating solution. So there is more efficient removal of debris and smear layer. Acoustic streaming, it is the formation of small but intense eddy currents or fluid movements around the oscillating instrument. This improves the cleaning ability of the irrigating solution through hydrodynamic stresses. Next is sonic handpieces. These sonic handpieces operates at a frequency of 2 to 3 kHz, which is much less than compared to the ultrasonic frequency. They are similar in shape and weight to dental handpieces and are attached to existing air and water outlets. They are used in a manner similar to ultrasonic system. Only difference is that sonic system uses water as an irrigant and requires special instruments known as Respisonic, Shapersonic, Triosonic or Heliosonic. The uses of endosonic is that for access refinement or enhancement, locating orifices, irrigation, sealer placement, gutta percha obturation, mineral trioxide aggregate placement, and endodontic retreatment procedures. So, to conclude, there is a vast array of endodontic instruments for various phases of endodontic procedures. A thorough understanding of the metallurgy, design characteristics, and use of different root canal instruments are essential for the successful outcome of endodontic treatment. Thank you.